This is the third section of the matrices chapter, and this is finding the determinant of a matrix. You'll find later that actually one of the reasons, or the main reason we find a determinant of a matrix, is to allow us to find the inverse of a matrix. But in this section, we're just looking at how we find the determinant. Now, for a 2 by 2 matrix, where I've got these elements, let's call them A, B, C, and D. So it's a square matrix, 2 by 2. If I want to find a determinant of that matrix, then I do A, I times it by D, so I times those two together, and then I subtract B times C. So I need to multiply these, and then I subtract them. Okay, so you minus that. So what we have is the let's call this A, this matrix. Yeah, the determinant of A is the number that we get from this calculation, AD minus BC. Now, this can take two values. So AD minus BC, it may be equal to 0, or it may be non-zero. Now, if it's 0, the matrix is known as singular. We'll find out later that actually means that there is no inverse. That comes later. Singular basically means there's no inverse. You can't find the inverse to the matrix. No inverse exists. Where if it's non-zero, okay, it's non-singular. So you could think of it as it's not single. It's got a partner, and its partner is the inverse. So in this case, there is an inverse. There is an inverse. Now, we don't want to keep writing the determinant of A is. So if we've got a matrix A like that, then we would write down det A. We could put in brackets. So this basically means the determinant of A is, and then AD, the first element times the fourth element, minus the second element times by the third element. Okay, you can do this on your calculator. If you press menu and you click option 4, that's your matrix menu. Now what you need to do is you're allowed to store 4 matrices in there, A, B, C, and D. So if I picked A, for example, number 1, I might say, right, it's got 2 rows and 2 columns. You then need to enter in what the value of each element is. After you've done that, you press equals. Then after that, once you've done that, you need to press option OPTN, and then you want to do a matrix calculation. For example, so I've pressed 3, and then I can do all sorts of different calculations on my matrix, including finding the determinant. But it's quite fiddly. Yeah, you'll be quicker, and it'd be better to find the determinant manually. It'll be much quicker. Yeah. Right, given that A is that, find the determinant of A. So the determinant of A, det A dta, is going to be 6 times 2 minus 1 times 5. Very easy. So that's 12 minus 5. So the determinant of this matrix is 7. So if I was asked whether it's singular or non-singular, it's non-singular. So if I needed to find an inverse, it's got one. Given that A is singular, find the value of P. So if A is singular, that means that the determinant of A equals 0, and the way that we find the determinant of A is AD minus BC. That is equal to 0. So singular means the determinant equals 0, basically means there is no inverse to this, and we need to find the value of P. So that means 4A times by D, which is 3 minus P, minus B, which is P plus 2, times by C, which is negative 1, that equals 0. So expand the brackets. So when we expand the brackets, we're going to get 12 minus 4P. And now here we've got a negative there, and we're multiplying by negative 1. So they're going to cancel out. So we'll basically have plus P plus 2 equals 0. So that gives me 14 equals, or 14 negative 4p plus p is negative 3p. Negative 3p equals 0. So that means that 3p equals 14 and p equals 14 over 3. So there we go. That's the value of p, and we use the fact that the determinant is equal to 0. Okay, so this question said find the minors of the elements 5 and 7 in the matrix, that 3 by 3 square matrix there. There are 2 steps in finding the minor of an element. The first step is to cross out the elements in the row and column of the element in question. So in the first bit it's 5 and then it's 7. The second step is to find the determinant of the remaining elements. Yeah. So let's do that. Let's start with 5. Let's find the minor of the element 5. So there are 2 steps. Step number 1, find the element 5 in the matrix, and it's here. Then cross out the elements in the same row and column as 5. Okay, I can see what I've been left with is 8, 1, 7, 3. So I've crossed out the elements in the row and column. Step 2 is to find the determinant of the remaining elements. So I basically want to find the determinant of 8, 1, 7, 3. Okay, now because we're going to be finding the determinant a lot, we can use 2 bars either side of the elements, and this means the determinant of the elements inside. So when you see 2 bars like this, okay, this basically means find the determinant, find the determinant. Right, so if we do that, that's going to be 8 times 3 minus 7 times 1. So we get a value of 24 minus 7, which is 17. Okay, so we say the minor of 5, or of the element 5 is 17. The determinant of the values that are left once we cross out all the elements in the same row and column. Right, okay, let's now find the minor of the element 7. Right, let's go back to our matrix. What we're going to do is find the 7, which is here, then cross out the elements which are in the same row and column as the 7. So we cross out these, we cross out these. You can see I've got 4 elements there, 5, 2, negative 1, 1. We write them in the same order. So basically now what I'm doing is finding the determinant of those 4 elements, which is 5, 2, negative 1, 1. Don't change their positions, which we can write as this. 2 bars, negative 1, 1, like this. And that's going to be 5 times 1 minus 2 times negative 1. Okay, so that's going to be 5 minus negative 2, which is going to be 7. So we can say the minor of the element 7, or 7 is 7. Yeah, so cross out the values in the row and column and use that to find the determinant of the elements that are left. Now you'll see some stuff up here in the box, and this shows us how to find a determinant of a 3 by 3 matrix. Okay, so the 2 bars around that 3 times 3 square matrix. So the determinant of a 3 by 3 matrix Right, so we start with element A and we multiply it. So element A is going to be the very first one up in the top corner. And we multiply it by its minor, multiplied by the minor of A. Okay, so that basically means work out the determinant of the elements that are left. So if I cross out those and cross out those, you can see that I've got EFHI. I work out the determinant of that. Minus B times its minor of B, plus C times its minor of C. Now you can see where there may be a possibility for problems where you've got the first one is a positive, then it's a negative, and then it's a positive. Yeah, that could cause some issues. So let's just take this out. Yeah, so we found it. If you want to find the determinant of a 3 by 3, find the element A, find the determinant of the minor. You move on to element B, and then you find the determinant of its minor. So it's going to be ACGH. Now I think that's wrong, isn't it? DF. No, it's not. I've just crossed out the wrong row. I don't know how to cross rows out. Top row. So it is right. I'm wrong. So cross out those, cross out those. So it is DFGH. And then for C, I do the same thing. So C, cross out all the elements in its row and column, and then we find the determinant of that and we multiply it by element C. So the determinant of a 3 by 3 is going to be a single number, just like it's a single number for a 2 by 2. And the same rules apply about it being singular or non-singular. So if this determinant is 0, it means it's singular. There's no inverse. If the determinant is non-zero, it means that there is an inverse. So find the value of the determinant of this 3 by 3 matrix. So remember, those bars mean we're finding the determinant of that matrix. So what we do, we start with element 1 here. And what we're going to do is 1 times its minor. Now its minor is going to be the determinant of the elements that are left. 2, 1, 4, 3. Then minus, it's always minus, got like plus, minus, plus. The minor of the element 2. So the minor of the element 2 is going to be the determinant of 3, 1, negative 1, 3. And then plus, so it always goes plus, minus, plus on this. The minor of the element 4, and the minor of the element 4 is the determinant of 3, 2, negative 1, 4. So 1 times its minor minus 2 times its minor plus 4 times its minor. So it's going to be 1 times, now the minor is going to be the determinant, so that's going to be 2 times 3 minus 4 times 1, minus 2 times 3 times 3 minus 1 times negative 1, plus 4 times 3 times 4 minus 2 times negative 1. So let's work that out. So it's going to be 1 times by 6 minus 4, which is 2. Next one, minus 2 times 9 plus 1, which is basically 10, plus 4 times, so that's going to be 12, plus 2, which is 14. So I don't really need brackets. 4 times 14. Right, so what do we get? 2 minus 20, 4 times 14, so that's double 28, 56. So all that's all we need to do. So I'm going to use my calculator and be lazy. So 2 minus 20 plus 56, and I get 38. So the determinant of that matrix is 38. Okay, the determinant, if we call this A, the determinant of A is 38. So this tells us actually that it's non-singular. There is going to be a matrix or an inverse for this. So the matrix A is that, and what we want to do is find a determinant in terms of K. So it's going to be the first element times by its minor, which is the determinant of the elements which are left, which is 1, 2, 0 and K plus 3. Then it's going to be minus K, the second element, times by its minor, which is going to be the determinant of negative 2, 2, 5 and K plus 3. Then it's going to be plus, the third element is 0, times by its minor, which is going to make our working a little bit easier. Negative 2, 1, 5, 0. Right, so let's work out what this is. So we've got 3 times. So it's going to be 1 times K plus 3 plus minus 0 times 2. So we'll just leave that as it is. It's just K plus 3 minus K times. Now the determinant of that is going to be negative 2 times by K plus 3. So that's negative 2K minus 6. Then minus 5 times 2, which is minus 10. Then, well, it's going to be this, isn't it? Yeah, 0 times by, and there's pretty much no point. We end up with 0 minus 5, so it's just gone anyway. Let's expand the brackets. 3K plus 9. Then these two here are going to make negative 16. So when we multiply out, we get plus 2K squared plus 16K, which pretty much looks like a quadratic to me. So I end up with 2K squared plus 19K plus 9. So that's the determinant of that 3 by 3 in terms of K. And guess what? Part B says, given that A is singular, which means that determinant is 0, find the possible values of K. So what we do is we make that determinant equal to 0, and we're going to solve it. Now, can I factorize it? Possibly. In an exam, you may not necessarily want to muck around with trying to factorize it, so you might just go straight to the quadratic equation. So A is 2, B is 19, C is 9. So we've got minus B plus or minus the square root of B squared minus 4 times A times C. Let's hope these are real solutions and not complex ones, divided by 2A. So what do we get as solutions for that? Do we get, it does say possible values, so I'm expecting there to be 2. So let's just type that in, big fraction sign, negative 19. Let's do the plus first. Square root 19 squared minus 4 times 2 times 9. Go down to the bottom of the fraction, 2 times 2. So I get negative a half as one solution. So negative a half. Now if I just scroll back and change that plus to a minus, I then get negative 9. So maybe it would have factorized not too badly. What would it have been? Something like 2K plus 1 and K plus 9. So it did factorize, but never mind, we've got the solutions. So possible values of K. K can equal a half, negative a half, or K can equal negative 9. Right, you should now be able to do exercise 6C on pages 106 to 109 of the textbook.